Hello and welcome to the Change Dude podcast, where we explore the intersection of technology, sustainability, and innovation. I am Saeed Rafe, your host, and today I am thrilled to have Dr. Akif Quddus Khan with us, a visionary researcher in cloud computing, big data, and machine learning. Therefore, this is a special episode because it is my very first episode in video format on the Change Dude podcast. Second, we have a guest here with us. So with this, I plan to begin this series of having guests and video format podcasts beside the usual weekly podcasts that are usually in audio format. So let's start. Dr. Khan's groundbreaking work in optimizing data placement and cost modeling in cloud environments is paving the way for more efficient, scalable, and sustainable cloud solutions. His projects, such as the storage tree optimization and cloud resource placement, and innovative graph-based cost optimization frameworks are not only driving technical advances, but also reducing energy consumption and the environmental impact of the data centers. My personal passion for GreenOps and FinOps, practices that promote environmentally responsible and financially efficient cloud operations, led me to dive deeper into his research work. I'm excited to learn more about how his work is making tangible difference for businesses and our planet. Welcome, Dr. Khan. Thank you for joining me today. I would like to first of all ask you to introduce yourself to the audience and describe your experience and research work as best as you like.
Thank you so much, Saeed, for inviting me. I can give a very brief introduction. I have over 12 years of experience in computer science and engineering. I have been taking on roles in software development, big data analysis, and cloud computing. My academic journey includes a PhD in computer science from Norwegian University of Science and Technology, NTNU. In my PhD, I focused on cloud cost modeling and optimization. And now I am bringing this blend of industry experience and academic research into the classroom. Right now, I'm working as an assistant professor at Oslo Metropolitan University. And here I teach web programming courses and I supervise bachelor and master thesis in cloud computing domain.
All right, so to kick things off, I would like to start with some questions about your research and its impact. Dr. Khan, could you share the inspiration behind your research in cloud resource optimization? What motivated you to pursue innovative models like the storage tier classification and graph-based cloud resource placement? And how has your journey evolved in this field?
Absolutely. So, first you need to understand that cost optimization in the cloud is not a small problem. It's not a simple problem. It's a massive challenge with several sub-problems. So I started researching this area about 5 years ago. And my first big contribution was a framework for smart data placement using cloud services. And the idea was to deploy big data pipelines in an hybrid environment where cost was actually just one of the factors alongside proximity, latency, and the impact of security protocols on the performance. So from there, I actually went deeper into the cost optimization problem. And in that domain, the first big challenge I ran into was the complicated pricing structure. So when you hear about cloud services and the whole pay as you go model, you might think, okay, I need 5 terabyte of storage. So I'll just pay for 5 terabyte of storage. Sound simple, right? But unfortunately, that's not how it works. So there are a lot of additional cost. For example, just to store data, you also need to pay for network services like uploading that data to the cloud, then downloading or retrieving that data. And the cost for storing that data also depends on the region where your data is stored. And then there are storage tiers, transaction cost, security fees. I mean, it all adds up. So you can see just to store that 5 terabyte of data, you are actually paying for a bunch of extra services. And that's when I developed a taxonomy for the structure of cloud cost. Basically, that taxonomy is mapping out where costs come from and then identifying the opportunities to optimize them. And since then, I have worked on novel frameworks for both storage and network cost optimization.
Your latest project involves a graph based model for cloud resource placement. Can you explain in simple terms how this model works? What role do graphs play in optimizing resource allocation? And why is this approach particularly effective compared to traditional methods?
All right. So first you need to understand that in big data pipelines, there are multiple compute steps, and the data flows from the very first step to the last. This basically gives us a predefined data flow pattern. So in our graph-based model, we represent cloud resources like storage and compute as graph nodes. And then by calculating the estimated cost of these resources and their related services that I just mentioned, then we assign that cost to the edges in the graph. And then we repeat this process for each step in the data pipeline. So once you have done that, you basically end up with a very complex graph showing all possible deployment options for your compute steps. And then you run graph theory algorithms to find the shortest, or in this case, the cheapest path from first step to the last. And you can even apply this approach to big data infrastructure deployed across different geographic regions. For example, in an ETL pipeline, you might collect data in one region, and then you move that collected data into a data warehouse and then use data marts to serve that data. So that's the basic concept of this graph-based model. Now to answer your question about why this approach is effective, first, it's industry independent. Second, it balances the cost performance trade-off, which is a complicated problem itself. Third, it takes into account the impact of quality service elements on the total cost. And most importantly, it has enormous scalability potential. I mean, you can add new cloud resources and you can literally seamlessly analyze all possible alternatives for each resource.
One of the exciting aspects of your research is its potential to reduce energy consumption and cost in cloud data centers. How does the graph based model contribute to both environmental sustainability and financial efficiency in cloud operations?
Well, that's a great question. So, as I said, this graph-based model actually breaks down the entire cloud operation into discrete steps. And with each resource represented as a node and the cost associated with them on the edges, by doing this, we basically identify the most cost-effective and energy-efficient pathway for the data processing. Financially, this means that we can optimize resource allocation to reduce unnecessary expenses like high data transfer fees or inefficient storage use. But in turn, if you think about it, this drives down the overall operational cost of running data centers as well. And on the sustainability side, by selecting the most efficient routes through our model, we naturally reduce energy consumption. And since data center consumes significant power, I mean, even small improvements in efficiency can lead to a meaningful reduction in the carbon footprint. So I believe in essence, the model creates a win-win scenario. It enhances the financial efficiency. On the other hand, it also promotes environmental sustainability.
Given my interest in both FinOps and GreenOps, I see a natural convergence in your work. In your view, how do financial optimization and environmental sustainability intersect in the realm of cloud computing? What trends do you foresee that could further enhance this synergy in the near future?
That's an important question. I see financial optimization and environment sustainability basically as two sides of the same coin, especially in the domain of cloud computing. So by streamlining resource allocation to cut cost, I think we naturally reduce wasteful energy consumption, which has a direct positive impact on the environment. For instance, with our graph-based model, we can analyze every step in a data pipeline to identify the most cost-effective and energy-efficient path. So basically, it's not only cost-effective, it's also energy efficient. So this not only minimize financial expenditure, I believe it also lowers the overall energy footprint of cloud operations. And looking ahead, I think trends such as serverless computing, increased adoption of renewable energy in data center, and AI-driven dynamic resource management, I think they are set to further enhance this synergy. And these advancements, they will definitely allow us to optimize workloads in real life, in real time. Um, I believe they will also ensure that every resource is used to its fullest potential, both in terms of financially and environmentally. So I think ultimately, as we push for better FinOps strategies, we are also paving the way for GreenOps, that is greener, more sustainable cloud infrastructures.
For companies looking to adopt cutting edge cloud optimization strategies, what practical advice would you offer? How can organizations begin to integrate these storage tier classification and graph based approaches into their existing cloud infrastructure to achieve both cost saving and sustainability benefits?
Okay, so to briefly answer your question, the first thing that anyone needs to do is eliminate waste, and that start with careful planning and auditing of cloud services. Now, your question about these models, the key thing to understand is that one of these model works in post-deployment phase, while the other works in pre-deployment phase. So for storage tier classification framework, I mean, company can easily deploy the solution on a spot VM on their server, or they can even use it as a software as a service. Similarly, the graph-based approach that is more suitable for pre-deployment phase, but company can still apply during the planning phase or to improve the existing big data applications.
Finally, could you share any insights into upcoming projects or emerging trends in cloud computing that particularly excite you? How do you envision the evolution of cloud resource optimization, especially in terms of leveraging data driven models for sustainability and efficiency?
Absolutely. At the moment, I'm doing research on developing new algorithms for compute resource optimization, and that is actually by making sure that resources are fully utilized and task scheduling is done efficiently. And one of the key areas I am exploring is how AI-driven models can dynamically adjust workloads in real time to minimize this waste while maintaining the performance. So again, balancing this cost performance trade-off. Looking at the emerging trends, I am particularly excited about the integration of predictive analysis in cloud management. So, I mean, by analyzing historical usage pattern, I believe we can proactively allocate resources even before the demand spikes. This will both reduce cost and energy consumption. Another trend that stands out is, as I mentioned earlier, is the serverless computing. That basically eliminates the need for over provisioning by automatically scaling the resources like only when they are actually needed. In terms of evolution of cloud resource optimization, I see data-driven models playing an even bigger role. For example, these machine learning and optimization algorithms will continue to refine cost performance trade-offs. And I believe they will ensure that the workloads are placed in the most efficient locations with the minimal energy consumption. Additionally, as more cloud providers commit to sustainability, we will see an increased focus on carbon aware computing, where workloads are scheduled based on the availability of renewable energy sources. So, I firmly believe that the future is heading towards smarter, more autonomous cloud infrastructure that optimize themselves for both cost efficiency and environmental impact. And that's where I see my research contributing. That is developing frameworks that make cloud resource management not only more intelligent, but also more sustainable.
Although you are currently focused on research and academia, however, are you currently or in future be interested in providing cloud optimization consultancy to businesses and organizations who might be interested in your research work and projects?
Said, I am more interested in creating impact rather than focusing solely on consultancy. So, when I discuss research in my classroom, I believe my students will carry these new approaches and principles into their professional lives. And this will have a long lasting impact. Similarly, when I speak at conferences, I see it as an opportunity to shape industry perspective and contribute to meaningful advancements. Having said that, if you believe consultancy could be a way to further amplify this impact, yes, I am open to exploring it.
Dr. Khan, thank you for this enlightening conversation. Your insights not only highlight the technical brilliance behind your research, but also emphasize its real world impact on making cloud operations more sustainable and cost effective. For our listeners who are eager to learn more, we encourage you to explore Dr. Khan's publications and follow his work for future updates. Once again, thank you for joining us today. It's been a true pleasure. Until next time, this is your host Said Rafi signing off from this episode of the Change Dude podcast.